3.2 secant line limits numerically. So we've got this equation again of slope of a secant line. Remember, a secant line is just a line that goes through two distinct x values. It's really y2 minus y1 over x2 minus x1. We're given a new function, f of x equals x squared minus 2x minus 19. It's graphed below. Determine the slope of the secant line of f for each of the intervals indicated in the table. And our interval is going from 3 to some other number, and our x2 is going to change. Write your answer as decimals. So first they want us to figure out if I found the slope from 3 to 4. And I use these brackets instead of parentheses to show that these are x values instead of an ordered pair. So what you could do is go through and figure out, okay, 3 3 comma what, and then 4 comma what. And I'm going to show you a quick way to plug in numbers here to your calculator. So on a TI, they have this button that's STO with an arrow. It's all the way here above the on button. You're going to first store an answer. So I'm going to, well, first we actually need to do 3, don't we? So I'm going to hit 3, then the store button, and I want to store it as x. You have to push enter so your calculator knows to store that. Now what I'm going to do is put this function in, x squared minus 2x minus 19. When I hit enter, what your calculator is going to do is replace every x with 3. And so that is negative 16. So when I plug in 3, I get negative 16. Now I'm going to do the same thing for the 4. Hit 4 first, hit store. We're going to store it as x again. You have to hit enter. Then I'm going to arrow up over this function again. If I hit enter, that'll bring it down here. If I hit enter again, it will plug 4 in for x. And so that is negative 11. This is just a way to speed you up a little bit so you don't have to keep typing every value in. And now what I would want to do is find the slope of these two ordered pairs. So it'd be negative 11 minus negative 16, so it'd be plus, over 4 minus 3. That would be 5 over 1, which is 5. So we have a slope of positive 5 from those 2 points. Now we're going to do from 3 to 3.1. And so we're trying to find the ordered pairs of those two x values. So what we're doing is we're starting from 3 to 4. Now we're kind of zooming in. We're getting closer to 3 because now we're only a tenth away from 3. And so we know when we plugged in 3, we got negative 16. The only one we need to do is the 3.1. So I'm going to put 3.1, store, as x, enter. I'm going to steal this formula, hit enter one more time, and it'll plug 3.1 in. So that's, ooh, I didn't write enough room. Negative 15.59. So my slope would be negative 15.59 minus negative 16 over 3.1 minus 3. So on the bottom, we already talked about we're just 1/10 away. Negative 15.59 plus 16 would be 0.41 divided by 0.1 will be 4.1. So my slope is now different from these 2 points than it was from these 2 points. So I want you to pause and try to find the secant slope for the last two x values. Kind of made a mess of my paper, but you should have gotten 4.01 and 4.001. So what's happening is this reminds us when we were learning about limits, how we would keep plugging in values that started to minimize in on something, and they got closer and closer to being more precise. That's what we're doing with the slopes of the secant lines. We're starting at an x value of 3, and they want us to find the slope from 3 to 4. We found that, and it's kind of hard on here, it's not colored, but it would be this line. And that's the average rate of change. Then what we're doing is we're taking this point and we're actually then zooming in or getting it closer at 3.1 and then seeing what the slope is and then getting it closer, 3.01. 3.001 would almost be on top of this. So what happens is we're getting more and more precise the closer the two x values are together. But we need those 2 points to find slope. We can't find slope from 1 point. So the slopes of a secant line is really like a limit. And that's why this lesson is called secant line limits. And what our slope at 3 is getting really close to is just 4. On the next page, number 2 says the function f of x equals x squared minus x minus 10 is graphed below. Determine the slope of the secant line of f for each of the intervals indicated in the table. Find the average rate of change of f on the interval from 2 to 2 plus h for each value of h shown in the table. Write your answers as decimals. This problem is basically the same as number 1 other than this 2 plus h. Well, they're giving us h values here. So this interval would be from 2 to 2 plus 1, which is 3. So you're going from an x value of 2 to an x value of 3. You would have to find the y values with those. This one would be from 2 to a 2 plus 0.1, which would be 2.1. Same thing. This one would be from 2 to 2.01. And the more decimals you get, the more decimals you're probably going to get as y values. And then this one would be from 2 to 2 plus 0.001 or 2.001. Okay, so go ahead and pause, try to find all of these average rates of change. Right, my average rate of change went from 4 to 3.1 to 3.01 to 3.001. So you can see that as we get closer and closer to x is 2, we're getting a slope of 3, and it's getting more and more precise as we zoom in closer and closer to 2.